Hey everybody, welcome to part 3 of the What is a Cloud video series. Hope you guys are doing well. So I want to circle back if you remember, and by the way, if you haven't watched the first two parts, you really want to go back and do that so the context is there for this particular video. But in the past video, we briefly talked about what a container was. And what we did with them. And we're going to talk a little bit more about containers now. So, containers, first off, they are not virtual machines. However, they're similar. The big difference is a container is a standalone piece of virtualization. It does not require a full blown guest operating system like Windows or like Linux or something else running in it. As a matter of fact, when we build containers inside of a cloud console, and I'm going to show you that later on when we get into our demo portion of this series, a few videos from now. I'll show you how to build a container. And the one thing you're going to notice, guys, when I build a container, I'm not building a virtual machine. Okay, from the customer perspective, meaning my perspective, not the cloud service provider's perspective, but my perspective, there is no virtual machine. I go into, for instance, the Azure console and I find the containers location and I build an application in a container. Now, it just so happens that that application actually is running on top of a virtual machine. I mean, that's what's going on. But from my design and build perspective, I don't interact with a virtual machine, even though the container is in itself running on top of a virtual environment. The cloud service provider is providing the hardware. They're providing the virtualized system, if you will, the virtual machine. So the host operating system runs with what's known as a container engine. Now, what's the host computer? That's the physical computer being run by the cloud service provider. That is running a container engine, like, for instance, Docker. Docker is kind of the universally accepted, at least within the cloud service provider world, it's a container engine. It's similar to the hypervisor found in Hyper-V server in the Microsoft world, or VMware server in the VMware world, if you will, for hosting virtual machines. Remember the previous part, I discussed how virtual machines share the hardware of the physical machine, and the hypervisor provides that abstraction layer between the two. Well, we don't necessarily have a full-blown hypervisor here with containers. We don't need it, because it's an application versus a full virtual machine. But we have something similar. It's called a container engine. And again, Docker is the kind of the de facto tool that we use. So that container engine does, in fact, operate very similar to a hypervisor. And of course, just like a hypervisor would allow multiple virtual machines to execute on a single host machine, the hypervisor allows those virtual machines to, again, share hardware, etc., with the physical machine. The container engine will allow multiple containers on the host system to run in their own kind of sandboxed environment. You know, you may have heard of that term, sandbox, when it comes to IT. And sandboxing basically means a separate environment for whatever it is we're sandboxing, usually an application. So if I have an application running in its own sandbox, nothing else is in the sandbox with the application. And again, the beauty of this is if that application happens to, I don't know, become corrupt or fail in some way, that application, because it's containerized, will not affect any other container being hosted by the cloud service provider itself. Kind of like, guys, you take food and you put it in a separate, like a pint container, and you put a top on it. If you forget that food and it becomes rotten, that food is not spoiling everything in your refrigerator, right? Same kind of a scenario. So the container engine, Docker in other words, which is similar to the hypervisor, allows many containers, excuse me, many containers to exist within the same virtualization platform. Again, whether it's a VMware platform or whether it's a Hyper-V platform in the Microsoft world or even a virtual box platform. Okay, this is what containers are. Now, what is the beauty of a container? Well, a container allows us to host applications. That's really what it's allowing us to do. I'm not hosting a full VM. I don't even visualize the VM. I'm not being charged for a VM. I am simply running an application inside of a container, and that application has its own environment to run. And then, of course, I'm being billed as the customer. I'm being billed whenever that application is being consumed by whoever's consuming it. Could be our employees that are working from home. Could be anyone throughout the world. Remember, ubiquitous access throughout the world. Anyone who needs to access our application. Could be a customer buying something. The thing you need to remember about these applications, however, is they must be web accessible applications. If you can't access the app over the web, then this is going to be useless. That application is not suitable for being put into a container. Container applications are accessed with things like HTTPS, accessed with regular old HTTP for that matter, or any other web-based process, maybe in a federated environment with SAML, which is the security assertion markup language. There's a bunch of things that you can use. So remember that the application that you may want to host in the container, this application has to support web access. What do I mean by web access? Oh, here's just a perfect example. And you're doing this now, right? You're visualizing, you're viewing this video on YouTube. You're sitting at home or in your car or in the office. Maybe you have your iPhone or you've got your computer or whatever you're using to see me right now. And you're connecting over the internet. You're using a browser or you're using a YouTube app. Right? So if I open up my Firefox or Chrome or Edge browser and I type youtube.com, I'm connecting to the YouTube environment. I'm searching for a video on the cloud. You find my video, you hit play, and now you're watching it. That whole YouTube infrastructure you're accessing over the web. I'll give you another example. You've got, let's say, Outlook. Outlook is an email client made by Microsoft, developed by Microsoft for connecting to Microsoft mail servers that are running Exchange. Well, I'm connecting to my Exchange server over the internet. My Exchange server is being hosted somewhere out on the internet. Okay, I'm not saying we put Exchange in the cloud. I'm just talking about how we access things over the internet. So we need to have an application that supports that level of access. Whether it requires a client piece, which is perfectly fine, meaning a client piece running on your computer to connect over the internet to it, like Outlook, for instance, or whether I just open up a browser and I connect to a domain name, if you will, that resolves to an IP address of this container. When I do my demo, you will see exactly that. So if you remember in the previous part 2, I had a graphic much like this, but it was for virtual machines. Remember, I had the Linux virtual machine and I had the Windows virtual machine. Kind of a similar diagram to this, except there's some core differences here. If you look at the host physical computer piece, the gray around, that again is representative of the cloud service provider's physical computer. That physical computer is running a host operating system, not a guest, a host operating system. That is the operating system installed on that host physical computer, whether it's VMware or whether it's Hyper-V. We then have the container engine. Notice it doesn't say hypervisor here. The hypervisor is for virtual machines. The container engine is for managing containers in a virtualized environment. And notice it says in parentheses there, Docker. Docker, again, is the universally kind of accepted, open source, by the way, container engine that these cloud companies have decided to use. And then above, it shows 3 containers. And I know it says container 2 twice. Forgive that. That is a mistake. It should say container 3. But container 1, container 2, and container 3, these are 3 separate applications, right? It doesn't say guest operating system. It doesn't show the Linux Penguin or the Microsoft flag, right? It says app, app, and app. These are applications. Now notice under those applications, you see dependencies listed there. Dependencies, what does that mean? Well, guys, applications have dependencies. Not all of them, some of them do. What does that mean? That means if I want to install that application, that dependency must be on that computer before the application is installed. So that means if I'm going to upload an application into my container and it requires a dependency application or service or driver or system file of some kind to be there, that must be there first. I don't know if you guys have ever installed some Microsoft applications where the Microsoft application requires .NET, some version of .NET 4.6.1 or whatever. And if you don't have .NET 4.6.1, you won't be able to install your application. You'll start the install process and it stops. It says, cannot go any further because .NET 4.6.1 is not currently installed on this machine. Go install it, come back, and run your install again for your app. Well, that's a dependency. So if your application requires a dependency, you need to install it before you install the application into the container. It's very simple. Now, you're not really installing it here either. You're uploading the dependency, you're uploading the application, and the cloud service provider is going to do the rest for you. So the Docker container engine is going to allow those containers to consume resources on the host physical computer, and the host physical computer would have access to those containers through the container engine. It's, again, an abstraction layer. Abstracting means to block, to hide. So the container has no idea it's a container. The host physical computer has no idea what the container really is. It's a virtualized system. And again, the cloud service provider may have 50, 60 containers running at the same time on kind of a mid-level virtualization host computer. If one of those if one of those containers happens to become corrupt in some fashion, meaning the application in some fashion has malware associated with it now, it's corrupt, whatever, and that container actually fails, if that container fails, well, no problem. It's not going to do damage to any of these other containers because this is a separate, isolated environment. So the container provides isolation as well. Again, think about it from the cloud service provider's perspective. Can you imagine if a cloud service provider has 25 separate customers, containers, on a host physical system, running harmoniously with Docker, controlling the whole thing? Can you imagine if one container becomes corrupt and takes out your entire container base? This would be extremely problematic, right? You'd have a lot of issues with that. Obviously, the customers would be upset. You probably would lose business because they can't trust that their applications are going to be truly isolated and running on those systems. Okay, so Docker, this is the open source container engine that is managing containers. What is it? It's a lightweight application, and it provides us a way to deploy applications without deploying full-blown virtual machines or full-blown systems. Now, the other interesting thing about a container is you can deploy whatever you want in a container, provided it supports web access. So you may have kind of a conglomerate application, or an application that has many different pieces in it, like a suite of applications within the application. Like the Adobe Creative Suite, it gives you Dreamweaver, It gives you Adobe Photoshop, Adobe Lightstream, all these different things. Well, do I have to deploy the entire Adobe Creative Suite, or can I just take individual pieces and deploy them separately in containers, which would make each one of them run better? Why? Because they don't have the overhead of all the other stuff. The answer is yes. We can deploy different pieces of an application into separate containers. Each of those containers is assigned its own resources. So have you ever installed a big application on your, say, laptop or your computer, and it runs really slow because of the overhead of all those other pieces that are a part of that application that you're not even using? Well, with a container, I can take that piece, put it in a container. I can take that one, put it in a separate container. That one in a separate container. That one in a separate container. Instead of one application made up of 10 things, now I have 10 applications running in their own containers with their own resources assigned to those containers, which gives us efficiency. It allows those applications to run much better and more efficient than if we just took the entire Creative Suite, the Adobe Creative Suite, dumped it in one container, assigned resources to it. We're going to get more efficiency, better performance if we isolate each of the pieces that we can into separate containers. Now, I said something important. Isolate each of the pieces if we can. Not all suite-based applications will allow for individual pieces to be extracted and run outside of the collective application. So you have to make sure you understand that. It's not 100% guarantee that any suite of applications I could separate the pieces. Okay, we talked a little bit about serverless computing yesterday as well. And we said we're moving even further away from virtualization. You know, we started with the VM. We just talked about the container. But I don't want to host an application. I don't want to have a full VM, if you will. I just want to host some code. I want to create a package. What is a package? A package is code and also a configuration file. We start off with a function, which is really programmatic code. What programmatic code? Whatever you program with. As long as it's a natively supported programming code, Python, C++, C#, all of these things are supported. Even general scripts from PowerShell and Z Shell and all these different things. So we take a function or programmatic code, and then we have a configuration file, and we combine those two things together, and we've created what's known as a package. Now, once I have that package, all I do is upload it to the server owned by the cloud provider, Amazon or Microsoft or IBM. So the cloud providers, what do they do on their end? Well, most likely they're going to have a container, and they're going to host that function in a container. We don't see the container. We don't have access to the container. I don't build it. I don't see it. Here's my function. You do the rest. So in a serverless, as we call it, in a serverless architecture, the cloud provider is going to create a container for it. And that cloud provider is going to manage and control all of the container and the underlying architecture that makes that container. Not us. They're doing it. I'm not managing DNS. I don't even know the parameters of the container. I don't know the IP address associated with that container. And yes, containers have IP addresses which tell you that containers run on virtual machines, because containers don't have network cards, right? Virtual machines and physical machines have network cards. So the underlying architecture goes from your function to a container to a VM being hosted on a physical host computer. Now, the interesting thing about this, much like an application container, I only pay when the application runs. I only pay the processing time that is used by the function. So if no one is executing the function within a resource, I'm not paying for it. I only pay each time the function executes. In the previous episode of this multi-part video series on the cloud, I said that, and I gave you an example, right? You went to the web, you filled out a form, and you hit submit, and all that data you entered into the form goes somewhere and is processed. That's the function, the processing on that data, not the form you filled out. That's just a web form in HTML. But the data and what's going to happen to that data, that is governed by some process. That is governed by a function. So maybe you're going to go register for something, some kind of a presentation, right? So you go to a website, you fill out this information that, your name, your address, your phone number, what day you want to go to the presentation and whatnot, and you schedule it, and then you hit submit. That goes over to a back-end database. It's collected, tickets are generated, and then you're emailed some tickets to go to this presentation. Well, all of the processing of that information, guys, is what I'm talking here about a function. Okay? Me, as the cloud service customer who set that up, I'm not managing a virtual machine. Don't even see it. Don't even know where it is. I know it's there, but I don't deal with it. I'm not setting up a container. All of that is done and managed by the cloud service provider. All my developers are doing is creating the function packages and the configuration parameters. We upload the function package to a server that's owned and operated by the cloud provider. The cloud provider puts that function in a container, which is on top of a VM, which is on top of a physical machine, and I am billed as that executes. That's how this process is going to work. Well, guys, that is, I want to wrap up here. I want to keep these around 20 minutes. So we're going to wrap up here with part 3 of this cloud series. When we come back, we're going to talk about another very important aspect of the cloud, and that's providing networking services. So we're going to talk about them. So I will see you back here for part 4. And we'll move through this series. Eventually, as I said, we're going to get to the demo portion where we're going to be spending a lot of time inside of the Azure console. And we're going to start putting these pieces together so you can have some visual assigned to the knowledge that you're getting by hanging out with me and going through this training. You guys have an awesome afternoon, awesome evening, wherever you are. Hey, do me a favor. If you have any questions regarding this content, let's treat this like a class, which it really is. Down in the comment section, ask your questions. I answer questions in the comment section. Do yourself a favor and subscribe to the channel, because I'm going to be putting out dozens and dozens of videos over the coming year. And that way you'll know exactly when, for instance, part 4 and part 5 and part 6 are going to go up. And of course, I'm going to move into security. I'm going to move into a lot of good things. So subscribe. Ask your questions. Hey, if you can share this video with someone that you may know who's interested in the cloud, it would be very helpful for this channel. Thanks, guys. I'll see you on the next one.